What up everybody, welcome to the second lecture of Trig. Today we're going to be talking about section 1.2, but before we do that, I want to talk about what I left off of last lecture. What I left off was all the stuff about the area of a circle. Now before I really get into the area of a circle, I want to tell you all a little bit of a story about myself. So when I was a kid, I hated family functions, hated them. I didn't hate them because I didn't like my family. They were alright, but like, who doesn't like going to see grandma, right? So I hated them because I had one little asshole cousin who always ate the pumpkin pie. One. Just one did this. So I come up with a plan and I'm like, alright grandma, this can't keep happening. What are we going to do? I was like, I don't know, it's up to you. Got you. Come up with this plan of cutting up the pie, kind of like what you see behind me. And all of these janky wedges that none of them are even, and they're pie wedges, but they're not the same like amount of pie. My plan is, I'm gonna cut it up so he thinks he's eating more, but really he's eating less. Grandma's like, all right, cool. You know I can just make you another pie. I'm like, look grandma, I gotta stay your favorite, so I'm not gonna make you do this. Like, low key, I wanna stay your favorite. So, grandma's cool with this. She makes this pie and cuts it up in this janky way. But in order to know how to cut it, I realized I have to know the area of the pie, and I have no way of doing this. Well, at the time, I didn't have the math to do what we're about to learn. But there is a way of cutting up this pie to make it so that it looks like some slices are going to add up to something bigger than what the other slices do. And like I alluded to, we need to know the area of these wedges, right? So what is that? What is the area of these wedges? Like, how do we find that? We know the area of the entire pie is pi r squared. Okay, that's straightforward enough. But what about a wedge? What about just a slice of this pie? What's that area? That area is found using the equation behind me. Voila. So what we've got here is we're saying, if I want to know the area of just a wedge of pie, well that area is going to be equal to 1/2 times the radius of the pie squared times whatever that angle is in radians. So we can think of the pie, or the slice of pie, like this, right? We know whatever the radius is, and we presumably know whatever that angle is. And using those two pieces of information, we can find out what the area of this slice of pie is. And I can look at my cousin and say, got you. Having said that, let's look at an example using this. So if in our notes we turn to the last example, what we've got is a sprinkler that has a reach of 70 feet ticking over only 120 degrees. And we want to know what the area of this bougie ass golf course that's getting covered by the sprinkler is. How are we going to do that? How are we going to find that? Well, we're going to apply that area formula that we were talking about just a second ago. We know in this problem what the radius is, right? And we know what the angle is, so we can just throw everything in, right? Not quite. The problem we run into is that our angle is given in degrees. Our formula only works with our angle in radians. We have to have it in radians. So the first step to this problem is converting our angle from degrees to radians. Okay, fair enough. We talked about that last class. To find our angle in radians, we're going to take 120 degrees and multiply it by pi over 180. When we do that and we reduce this all down, what are we going to get? Well, first, reducing it down, we're going to get 12 over 18 times pi, which we can reduce down. We can divide 12 by 6 and 18 by 6. And we're going to get that our angle in radians is 2/3 pi. From here, it's just a matter of throwing everything back into our formula. From here, throwing everything in, we find that the area is equal to 1/2 70 squared times 2 over 3 pi. Really quickly, we might notice that this 1/2 and this 2 is going to cancel, are going to cancel. My English not so quickly. So when we do that, what we're left with is 70 squared times 1/3 times pi. And the rest is really just arithmetic, so I think I'm going to leave it here and get on with the rest of lecture. The rest of this calculation you can find in your notes. You're just going to square 70, and then multiply by 1/3, and then multiply by pi. So let's move on. Before we get into the basic trig functions, I want us to talk a little bit about the unit circle and what the unit circle tells us. The unit circle, some background to it first. The unit circle is a tool that mathematicians and scientists use the world alike. And in this particular class, as we move through the semester, you're going to find it's a very useful tool to know, to have memorized. It could very easily be the case that having this memorized will be the difference between passing and failing. It is a very, very useful tool. Having said that, what is it? What does it tell us? Well, to begin with, the unit circle is an observation about things relating to a circle of radius 1. Duh, it's a unit and it's a circle. Radius 1, right? Thanks, Sherlock. Okay, guys, thanks for the sarcasm. So, the unit circle, having said that it's observations relating to a circle of radius 1. What those observations are about angles of measurement from the x-axis and where corresponding points along the edge of the unit circle will lie. Okay, what does that mean? Tell it to me in English. What that means, what I'm saying. is that the unit circle tells us how measuring an angle from the positive x-axis up relates to the points, the xy values of the points that lie at the edge of the circle. So for example, pi over 6. If we were to look at the unit circle, move up pi over 6 radians, so we're tilting up, right? We would find that the xy value at pi over 6 radians is the square root of 3 over 2, that's the x value, and 1/2, that's the y value. So this is the coordinate of that point on that circle at pi over 6 radians. Having said that, if we go another pi over 6 radians, so now we're looking at pi over 3 radians above the x-axis, the xy coordinates now become 1/2 and the square root of 3 over 2. Now, I kind of skimmed over something. I didn't talk about the x-axis and I didn't talk about the y-axis. What are these 2 points of the circle? Well, assuming the circle is centered on 0, like what I've already kind of suggested here, if that's the case, well then the x-axis, when our radians is 0, should be 1, and our y-axis should be 0. So we should have an x value of 1 and a y-axis, a y value of 0. Then if we go to 90 degrees, so we're along the y-axis, then the x value should be 0 and the y value should be 1. Having said that, some cool things start to happen now. Once we pass the y-axis, everything mirrors on this top, except our x values become negative. So, what I am saying is, if we move at first pi over 6, and then pi over 3, and then pi over 2, and now we go to 4 pi over 6 radians. So we're at 2 pi over 3 radians. What we'll see is our x value is negative 1/2. And our y value is the square root of 3 over 2. And if we move another pi over 6 radians, we're going to see our x value is negative square root of 3 over 2, and our y value is 1/2. And then if we go another pi over 6, we're going to find that our x value is negative 1, and our y value is 0. And then if we move down below, now we have all of our y values are negative. Now it's the mirror image this way. So what we have at 7 pi over 6 is going to be an x value that's negative square root of 3 over 2, and a y value that's negative 1/2. And if we go another pi over 6 radians, what we're going to have is an x value that is negative 1/2, and a y value that is negative square root of 3 over 2. Now I'm going to leave this final quadrant for you all to figure out. And really what I'm trying to point out is what the unit circle tells us is on a unit circle, if we're going to move up so many radians, what can we expect the xy value along the circle, the edge of the circle, to be? Traditionally, we use pi over 6 radians when talking about the unit circle, and we throw in oftentimes one other set of angles. All those angles that occur at pi over 4 radians. So pi over 4, so forth and so on. You know what I mean? 3 pi over 4, 4 pi over 4, etc., etc., etc. And I'll talk about those in just a minute. But in the meantime, I want to get back to the trig functions now, or I want to get to the trig functions. When talking about trig functions, all we're really doing is relating the angle to something about the unit circle. That's all it does. And this is why the unit circle helps us so much. Is because trig functions essentially at their core tell us only something about these. That's it. Having said that, the cosine of an angle tells us what the x value is on our unit circle. So cosine of an angle is x. It's the x coordinate along the unit circle. Sine of an angle, well, that's going to be y. That's the y coordinate. Now I'm going to tell you that the tangent of an angle I don't want to say it that way. I'm thinking about how I want to say what I want to say. Yeah, I do want to say it this way. So, the tangent of the angle is equal to the sine over the cosine. Sorry about that freeze there. Like I said, I was thinking about how I wanted to tell you all this. So if the tangent is equal to the sine over the cosine, what does that tell us about the tangent? What's the tangent equal to? Well, we can reduce this, right? We can just substitute in y for sine and x for cosine. So let's do it. Tangent then of an angle is equal to y over x. Secant is equal to 1 over cosine. So playing that same trick, well, we can just substitute in x for cosine. Dope. That's 1 over x. Cosecant is equal to 1 over sine. So we can just substitute in y. In cotangent, same trick. Cotangent is going to be 1 over tangent, so that's x over y. And these are our basic trig functions. Cosine of an angle is equal to the x position at that angle along the edge of our circle. Sine of an angle is equal to the y position at that angle along the edge of our circle. Tangent is the quotient, so we're just dividing y by x at that angle. So what we're doing is we're saying, all right, let me go to tangent of let me go to this, whatever the angle is. Let me find out what the x value and what the y values are. Tangent at that angle is going to be whatever the y value is divided by x. So tangent of pi over 6 is going to be 1/2 divided by the square root of 3 over 2. That's really all I've got to say about trig functions. Let's look at a couple of examples. So let's say we're asked to find the cotangent of 60 degrees. We don't know what the cotangent of 60 degrees is because the unit circle is given to us in radians. So how are we supposed to work on this? How are we supposed to solve this? Step 1, turn the degrees back to radians. Okay, we know how to do that. To do that, we're going to take 60 times pi over 180 and this is going to give us pi over 3. Okay, well we know that. We know what the unit circle tells us for pi over 3 radians. That's this top purple case up here, right? We start off at pi over 6, then we go up to pi over 4. Next we're at pi over 3. Well, at pi over 3 radians, let's step back actually a little bit more. Next we want to know what cotangent is, right? Cotangent is 1 over tangent. And tangent is equal to sine over cosine. So cotangent is equal to cosine of our angle over the sine of our angle. Okay, so let's find cosine and sine, right? Like that's the next obvious step. Cosine of our angle is equal to x. And sine of our angle is equal to y. It's the x-coordinate and the y-coordinate along the edge of our circle. So now we can start really solving this problem, right? And now we can say, all right, cool. Based on my unit circle, cosine of pi over 3 is equal to the x value at pi over 3 radians up along the edge of our circle. Well, the x value there is 1/2. So cosine of pi over 3 is 1/2. The sine of pi over 3 going up pi over 3 along the edge of our circle, looking at the y value, is square root of 3 over 2. So the sine of pi over 3 is going to be the square root of 3 over 2. So we know what cosine of our angle is, and we know what the sine of our angle is, and we know how those two things relate to cotangent. We know that cotangent of pi over 3 is equal to cosine of pi over 3 divided by the sine of pi over 3. And we now know that those are equal to, well, that whole fraction would be 1/2 divided by the fraction square root of 3 divided by 2. And this, after we reduce everything, is going to be 1 over the square root of 3. I'm going to leave the reduction up to y'all. That's what it comes out to be. So you can already kind of see here a little bit how this unit circle can be helpful. Knowing this, having just this memorized, and knowing how your trig functions relate to it, again, this is going to help you through 90% of the class. It can be the difference between passing and failing. I saw it before, I've seen it before, I should say, and I'm sure I'll see it again in the future. Knowing that one detail, these one sets of principles, huge. They really do help. Having said that, let's move on. Let's breeze through some quick definitions, because I know it's everybody's favorite, right? To start off with, let's look at this definition here of periodic. When we say a function is periodic, what we're saying is there exists this constant that whenever we add it to our variable and pass that through our function, it always comes out to be equivalent to if we had just passed the variable through our function. So what I mean is, we've got our function f of t. We're going to say, all right, cool. Let's imagine there's this constant. If I can add this constant to whatever my variable is, and then apply the function to it, if that always comes out to be the same as the original function without the variable added in, well, then our function is periodic. As two examples of what it means to be a periodic function, we have sine and cosine. And we say that they are 2 pi periodic. So what that means is, let's say I have cosine of whatever. Cosine of whatever plus 2 pi is equal to cosine of whatever. It's like I did nothing to it, all because I just added 2 pi to whatever. It did nothing. It just, boop, started back to where we began. And it makes sense when you think about all of this in terms of the unit circle. Think about what our cosine tells us. It's the x value as it relates to the angle, right? We put in the angle and out shoots the x value from our cosine function. Well, if that's the case, this is on a circle. And we know after going 2 pi radians, we are right back at where we began. So no matter where we started, we've made an entire circle back and ended up exactly where we are. Same thing with sine, right? Because it's just the y value. It's because of this that we say sine and cosine are 2 pi periodic. Notice, I want to push this point. Notice the unit circle is what I just referenced. I went back to the unit circle to reason that out, right? And please, 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 go back to your book and look at it just to see for yourself what I'm saying. If you need a copy of the unit circle with the quarter angles, can be found in the back of the book. It's the second to last page, I think. But anyhow, know the unit circle, right? Odd functions. If a function is said to be odd, then when we pass a negative variable through it, it's equal to the negative function. So, well, wait, what? What I'm saying is we take f, our function, of negative t. If that is equal to negative f of t, then our function's odd. 3 examples of that: sine, cosecant, tangent. Finally, even. We say a function is even if that function applied to the negative variable comes out to be equal to that function on the variable itself. Wait, what? So if f of negative t is equal to f of t, then the function's even. Cosine and secant are examples of even functions. If I took cosine of t, that is equal to cosine of negative t. This is what it means to be an even function. Just for some background, because I'm sure y'all, like I was, are curious, why the hell are these called odd and even functions? What do they have to do with being odd or even? They come from upper level maths. When you break these functions up, you can use what's called a series. When you do that, they have particular properties. And these properties is where we get the names odd or even, for whatever that's worth. Cool, let's use it all. For this final example, I'm just giving you half of the unit circle, right? And what you've got here is the unit circle with the radians pi over 6 marked, pi over 3 marked, 5 pi over 3, and 11 pi over 6. So you have 4 different positions marked on your unit circle, and it's only that half of it, right? And with it, we want to find out what the sine of negative pi over 3 is. We also want to find out what the cosine of negative pi over 6 is. You might be looking at these and being like, and thinking to yourself, well, they're 2 pi periodic. So why don't we add 2 pi to both of these? I like that. Let's do that. So if we do it to sine, we're going to say, all right, this is equal to 2 pi minus pi over 3. You might be thinking to yourself, okay, well, I can reduce this. So let's reduce it. Let's first turn 2 pi into a fraction, and then reduce the algebra. When you do that, you're going to get 2 pi turns into 6 pi over 3 minus pi over 3. We can easily reduce this. This is equal to 5 pi over 3. So the sine of negative pi over 3 is equal to the sine of 5 pi over 3. And we found it by taking advantage of the fact that sine is 2 pi periodic. Cool. Well, excuse me, chalk dust. Well, we know what the sine of 5 pi over 3 is by looking at our unit circle. Our unit circle, going 5 pi over 3 radians, tells us that the y value is equal to negative square root of 3 over 2. So the sine must be negative square root of 3 over 2. Notice for a second that if we wanted, we could have looked at our unit circle and we could have said, hey, if I go backwards, negative pi over 3, where does that land me? We could have asked it that way, right? We could also say, sine is odd, isn't it? Yeah, I think sine is odd. So that means, I'm going to erase all of this really quick. So that means the sine of negative pi over 3 is going to be equal to the negative sine of pi over 3. Right? Because we just said sine was odd. And this is what it means to be an odd function. The sine, or the function of a negative variable, is equal to the negative of the function applied to the variable. So the sine of negative pi over 3 is equal to negative sine of pi over 3. So looking at this, you know it's negative whatever the sine of pi over 3 is. Well, the sine of pi over 3 is the square root of 3 over 2. Lo and behold, you get the same answer. Well, that's convenient. Excuse me. All right, so let's look at cosine then. In the case of cosine, let's use the fact that cosine is even. Even functions are the case where if you pass a negative variable through, so we have f of negative t, that's going to be equal to just f of t. So here, cosine of negative pi over 6 is going to be equal to cosine of pi over 6. Well, I'll be damned. That shows up here, doesn't it? Yeah, it's the square root of 3 over 2. Now we could have gone about this another way. We could have used that it was 2 pi periodic. If we had used the fact that this was 2 pi periodic, we would have found ourselves at 11 pi over 6. Which, looking at this, 11 pi over 6, lands us at the square root of 3 over 2. So, the point of all of this is to say, know the unit circle. Know it, know it, know it, know it, inside and out. Obviously, it's going to be really helpful. And take advantage of the fact that trig functions are periodic, and some have odd properties, others have even properties. These very few things, these 4 facts, these 4 tools, they're going to save you. You're going to get to a problem at some point in this class and you're going to look at it and you're going to be like, I don't know. Don't give up on it. Don't let yourself get mad about it either. Because once you let yourself get mad, you're lost. Instead, stop, take a break. 30 minutes or so, whatever it takes. Go watch an episode of the new Star Trek on Amazon Prime if you want. Whatever it takes. I don't care. Just take a break. Come back and ask yourself if you can use one of these things that we just talked about. But definitely take a break. Yeah, having said that, that's all I've got for y'all today. If you have any questions, please, by all means, shoot me an email. I know today's lecture was a little testy. Yeah, have a good one, guys.